It's funny. We distribute, yet things multiply. Kind of sounds like a paradox, right? But today, we're going to see how this one beautifully simple idea secretly runs so much of the math you already know. It's all about breaking things apart in a really clever way to make multiplication way, way easier. So let's just dive right in.
Okay, let's get the brain warmed up. I've got a little puzzle for you. Imagine you've got the product 23 times 27. Simple enough. But what happens if we just nudge that second number up by 1, so it becomes 23 times 28? By how much did the final answer increase? No calculators. Just take a second and think about it.
Got an answer? The increase is 23. Yep, that's it. Simple, right? You might have even guessed it. But look, getting the answer isn't the point. The real magic, the thing we're here for, is understanding why. Because that why unlocks pretty much everything.
And to really get to the heart of it, we're going to do something a little different. We're going to stop thinking in numbers and start thinking in pictures. Seriously, we're going to make this whole idea visual, something you can actually see.
All right, Section 1, Thinking in Pictures. As they say, seeing is believing. Okay, so check this out. Forget the numbers for a second and just look at this rectangle. Its height is A, and its width, it's been split into two chunks, B and C. So the area of the whole big rectangle is the height, A, times the total width, which is B plus C. Makes sense. But you can also just see it's made of two smaller rectangles, right? The first has an area of A times B, and the second has an area of A times C. So the total area is just the two parts added together, AB plus AC. This picture, this is the why behind our puzzle.
So that picture we were just looking at, that elegant, simple idea, it has a name. And it is so much more than just a neat trick. It's like the master key for algebra. It's the source code behind so many things we do with numbers. And here it is in all its glory, the distributive property. It simply says that for any numbers, A times the quantity B plus C is exactly the same as AB plus AC. Let's think back to our puzzle. We had 23 times 27 plus 1. All we did was distribute that 23. First to the 27, that was our original product, and then we distributed it to that extra 1, which gave us that increase of exactly 23. See? It's not magic, it's a property.
And get this is not some new idea. People have known about this for a long time. We're talking about the great Indian mathematician Brahmagupta, who described this exact method almost 1,400 years ago. He called it multiplication by parts. I mean, how cool is that? It's a truly timeless piece of logic.
Okay, so we've seen the picture, we've got the formal name. Now let's get to the really fun part. Let's see how you can use this to unlock some honest-to-goodness mental math superpowers.
Ready for this? Here's how to multiply pretty much any number by 11 in your head. First, you just write down the last digit of your number. That's the last digit of your answer. Easy. Then, working from right to left, you add each pair of digits that are next to each other. And finally, you just write down the very first digit of your original number. Now there's one little catch. If any of those pairs you add up are 10 or more, you just have to remember to carry the 1, just like in regular addition.
Let's try it out with a big one. 3,874. Okay, you ready? The last digit is 4, so we write that down. Next, 7 plus 4 is 11. So, write down the 1, carry a 1. Next pair. 8 plus 7 is 15. Plus that 1 we carried makes 16. So we write down the 6, carry a 1. Next, 3 plus 8 is 11. Plus the 1 we carried is 12. Write down the 2, carry another 1. And finally, the first digit is 3. Plus that last one we carried is 4. Put it all together, 42,614. Boom. And why does this crazy trick work? Because multiplying by 11 is just a sneaky way of multiplying by 10 plus 1. You're just distributing the 3,874. It's our master key again, just wearing a disguise.
But, this property is so much bigger than just a cool party trick. It's a foundation. It's one of the most fundamental building blocks of algebra. It's the tool we use to take complicated expressions, pull them apart, and put them back together in ways that make sense.
I mean, take something you've probably seen before, a plus b squared. How do we even figure out what that means? Well, it's just a plus b times another a plus b, right? And to expand it, you just use the distributive property twice. First, you distribute the a to the second a plus b, then you distribute the b to that same a plus b. And when all the dust settles, you're left with that famous result, a squared plus 2ab plus b squared.
And just to bring this whole thing full circle, let's go back to where we started, with pictures. Check out this square. Each side has a length of a plus b, so its total area has to be a plus b squared. But just look at it. You can literally see it's made of 4 smaller pieces. You've got one square with an area of a squared, a smaller square with an area of b squared, and then 2 rectangles, and each of those has an area of a times b. So what happens when you add them all up? You get a squared plus 2ab plus b squared. The picture proves the algebra. It's perfect.
So there you have it, the distributive property. It's this one simple idea, just breaking things apart, that lets us build up almost the entirety of algebra. It's hiding everywhere. Which leaves me with one final question for you. Now that you know what to look for, what other math rules that you've learned are just this one powerful idea in disguise?